everyone. So let's solve today's LeetCode POTD. Best time to buy and sell stock 5. So the problem states that we are given an integer array prices where prices of I will be denoting the price of a stock in dollars on the ith day, and we are also given an integer k. Now we are allowed to make at most k transactions where each transaction can be either of the following. So either we can do a normal transaction, that means we buy on day I and then sell on a later day j. Then the profit will be profit of means prices of j minus prices of I. Or we can do a short transaction, short selling transaction. That means in day I we can sell that. So we can sell on day I and then buy on a later day j. So in this case, what will be the profit? It will be prices of I minus prices of j. Okay, because we have sell for this amount and we have bought for this amount. And here we sold for prices of j and we sell means bought for prices of I. Okay, now we must complete each transaction before starting another, because means once we have means at a particular time we can only have one stock at a hand. Okay, additionally you can't buy or sell on the same day, and these i's and j means selling and buying will be happening on different days, and we need to return the maximum total profit that we can earn after making at most k transactions. And this k means at most like n by 2 transactions we can make, because a single transaction will means take 2 days, a minimum of 2 days. Okay, so this k is from less than equals to prices dot length by 2. Okay, so like this is the fifth part of the problem. So if you have like read previous problem statements of means previous parts like 1 2 3 4, you might like know like we will either solve this greedily or like dp will be applicable here. So even if you have not read it before, like I will be discussing how like to means check whether greedy is applicable, or like we'll be applying dp here. Okay, so let's see the given input first. So we are given the prices as this. So let's try to see like what gave me the maximum profit that we can achieve. So we know like this one is very small, so maybe we can buy at price 1. So we buy at price 1, so the profit means profit will become, since we are buying at price 1, so the profit will be decreased by 1, means we are giving away minus 1 money. Now we see like 7 is increasing, 9 is increasing, so maybe you can like till maximum point we can sell it. So at this point we sell this stock, so means we earn plus 9. Okay, now we know like we have 8 and 2, so we have the capability of short selling transaction. That means we can sell on day this and then buy on later day, because this value is greater than this. So what you can do is you can sell this 8 means plus 8, and we can buy at a later stage at price 2. So 8 minus 2 equals, so this will be simply 8 plus 6 equals to 14, which is the maximum profit here. Okay, so once we like analyze the constraints, we see that prices length can go up to 1e3 only. Okay, so maybe a solution of the order of n square is expected here, n square or n into k. Okay, maybe some solution of the order of this complexity is expected. And like we know like when we are at a particular index, when we are at, suppose this was the prices array, so when we are at a particular index, we know we need to know like how many transactions we can complete more. Okay, maybe we have reached here by completing one transaction or two transaction, or we are in the middle of transaction, we have sold some value here and now we have not like bought it in short selling, or we have bought some value here and have not sold it yet. Okay, so there can be multiple ways we can reach a particular index, right? So what are the states that we can change? So dp states that we can change here is, once we have reached this particular index, then we know like the number of transactions that we have completed. Okay, so suppose it is the count of transactions that have been completed so far. So even if we are in the middle of a particular transaction, that means we have bought it and yet not sold it, that means that particular transaction has not been completed. Okay, so we will not be counting it as a part of the count. And along with that, what is changing, like whether we have the stock that we have at hand, either we'll have no stock, so let's represent it by 0. Then we have like a normal stock, means we have a stock which we like gave minus prices of I and we gaining prices of j at like whenever we sell it. Okay, so we'll have a normal cell. So normal cell, we have a given stock, which means let's suppose denoted by 1, and then we have a short cell, let's denote it by 2. Why we are like denoting it by 1 and 2? Because suppose we reached at index, and now we're at a particular index, index 1. We know like the current stock that we have is normal sell. So then the prices that we'll be adding in our result will be plus of prices of index 1. Why? Because in normal sell we'll be able to sell this stock at index 1. But in like short sell, if this value is 2, that means the price means the stock that we have at hand will be like buying it at a later date, right? So hence instead of plus, here it was plus, in this case it will be minus of prices of index 1, right? Because we will be like buying that particular stock at this index 1 day. Okay, so that's why like segregating these two values is important here. So hence there are three possible states that we can have when we reach a particular index. So hence this will be like suppose denoted by like the last. Okay, so this is the DP, and I hope like it is clear that we have like reached maximum profit till means 0 till index with count transactions performed, with last denoting what? Last denotes that this. Okay, so if last is 0, we have no stock at hand. If last is 1, that means we have a normal stock to sell, and if last is 2, that means we have a short stock which we will be buying at later stage. Okay, so like we know like we cannot do it greedily, because we know like whenever like we want to buy or sell stock, we have the choices of like buying it normally or means buying it in a short selling manner. So like that's why we cannot do it greedily, or greedily decide which stock will be like giving us the maximum profit and which day to buy it and on which day to stop. So that's why we saw like what are the states that are changing here. And on saying we saw that the index will definitely change. The number of transactions that we have means already performed, because there is a constraint on number of transactions, because we can only means use at most k transactions. Okay, so this count will change as well as this list. So what will be the like the maximum the range of this DP? So since index will going till n, this count can go up to less than equals to k. Okay, so this will be of the size of k plus 1, and this last can have three values, and it will be 3. Okay, so this is the initialization of the DP. Now let's try to see the transitions. Okay, transitions. So I will like try to explain you the memoization code, so that like the transitions become clearer and you will be able to like visualize how the transitions are happening. So there are three cases. Okay, the first case is the last is equals to 0. Okay, that means we have no stock at hand. No stock at hand. So in this case, what you'll do is, since last is equals to 0, so either we can like means normal buy, we can either buy it normally, or we can like short sell, or we can like do nothing, so we can skip. So this skip thing will be like doing it, it is possible at every step, because we are not bound to, since we want to maximize the total profit, we need to account all the possibilities. So skipping at a particular day, like do not performing any buy or sell, is also a like good thing. Okay, and we are at an index and we are at count. This is the last value. So in this case, since we are normal buying, that means we are paying something. So if we are paying something, the result will be simply what? It will be minus of prices of index, and plus now we'll be calling the memo function for further values. So the memo function will be moved to index plus 1. Now since we have bought a normal buy, so normal buy will be denoted by what? The last will be denoted by, since we are now we need to sell normal, so it will be denoted by value 1. Okay, so index plus 1, the count will still remain the same. Count will only change when we are like the transaction is ending. Here the transaction, it is the first step of the transaction, so this count will remain the same only. Okay, so it will be like this count still remains the same, and this last will be changing to 1. Okay, so this is what the means the profit at this step will be. Now the second step is to short sell. Okay, so for short selling, what you can do is we can sell at current day only. So what profit will earn? We'll earn plus prices of index. Okay, we'll earn plus prices of index. And now the next, we'll again call the memo function what? For what? for index plus 1 count, and now since we have short cell, that means we need to identify it differently. So that's why we identified it by this value 2. Okay, so this will be, means this last will become 2 now. And the second is to simply skip it. So skip will be simply memo of index plus 1, and everything else count and last remains the same. Okay, so hence in the for the last equals to 0, these will be 3 values, and we'll be taking the maximum of these 3 to get the profit. Okay, now for last equals to 1, last equals to 1, that means like we a normal cell stock had at hand, normal cell stock at hand. That means we have already paid the price. Now we'll be able to sell a particular stock, okay, at a particular day. Okay, so that means we'll be able to like normal sell because we initially bought it, so now we can sell it. Okay, so what will price we'll get? So we'll get plus of prices of index, and now plus what? We should be able to like see this memo of index plus 1, and now this transaction should be completed. Okay, this transaction is completed, means we'll be increasing the count by 1. So count plus 1, and now this complete transaction has been completed. So this last value will become like we will have no stock at hand now. So this will become 0. Now we also need to make sure that this count plus 1 should be less than equals to k. Okay, so we need to make sure that we are only performing these transactions. We are only performing these transactions when the count value is less than k. So as soon as like count becomes greater than equals to k, we can simply like return before we execute these statements. Okay, so that will be fine here. Now we can perform normal sell. Can we perform short buying? Short buying. So we know like last was 1. So that means we did not perform this transaction. So hence we do not have a stock which will be like which you can short buy. So hence that transaction will not be performing here. So hence the other transaction will be simply skip. So skip will be what? Skip will be the same that we did. Memo of index plus 1, comma count, comma last. Everything else remains the same. So in this case, we will be taking the maximum of these two values to get the current result. Now comes the case for last equals to 2. Last equals to 2 means we have short buy. We need to short buy stock at hand. Okay, means we short sell initially. We short sell initially, then it became 2. Now we need to short buy it. Okay, so then the case was short buy. So in this case, what we'll do? We need to pay some price. Okay, so it will be negative of prices of index, and plus again it will be becoming the same. The same function will be called memo of index plus 1, count plus 1, and the last will become 0 because a particular transaction has been completed. And the other case will be to simply skip because perform no operation here. Okay, or no performing of like buying or selling stocks. So in this case, index plus 1, count, and last. Okay, so these will be like the transitions for this last equals to 2, and we will be taking the maximum. So I hope you are able to see like how on the basis of different values of the last, we are able to define the transitions. So if we have no stock at hand, then we can perform like either normal buy or short sell, or like simply skip. And if we have last equals to 1, that means we have a normal bought stock at hand. So hence we can sell it normally. That means normally selling it will give plus of prices of index, or skip it. And last equals to 2, that means we short sell initially. Now we need to buy it. So that means we will be getting minus prices of index current profit at current step, and we'll be calling the same function for the indices, and we'll be changing the count as well as the last value accordingly. So these are the transitions that we follow at each step. Now we can simply write the memoization function to solve it, and we'll be like initializing this dp with -1, so that and see whether the solution for this memoized already exists or not, and if it does, then we'll simply return it or update our dp with the maximum of these values at each step. So I hope you are able to like grasp the transitions that are happening here, and let's see the code so that it becomes more clearer. So we'll initialize a dp of size like n cross k plus 1 cross 3, initialize it with -1. Now the state with which you calling it will be simply memo of 0 for index 0. Number of transactions that we have completed so far is 0 only, and currently we have no stock at hand, so last value will also be 0. Okay, so we'll be calling the memo function for these 0 0 0 values. Now let's see the transitions. Let's see the memoization function. So we have these three values: index, count, and last. So as soon as this index becomes n, we should know like we should not have any stock at hand. Okay, so since if this index becomes n, that means we should not have be having any stock at hand. That means this last should be 0. So in this case, if last equals to 0, then we'll simply return 0, as we return a very small value, so that the entire profit declines and it will become negative. Okay, so if last is 0, then we simply return 0. That means a valid valid way of ending the entire prices array has been reached, else we will return a very small value. Now we'll see like whether this states are already being calculated or not. If it does, then we'll simply return it. Now we'll see like if count is less than k, then only we can start a particular transaction for last equals to 0. Okay, otherwise we will not be starting it. So if count is less than k, we can simply write the three transaction. It will be like normal buy, then it is short sell, and this is the skip. So it is same minus prices of index plus 1 count, and this last becomes 1. Then in this we'll be selling it, so plus prices of index, then index plus 1 count, and this last becomes 2. And skip will be simply calling for index plus 1 count last. And for this current state, we'll be taking the max of these three values. Now comes the second case, so here will be normal selling or buying, normal selling or skipping. So normal selling means we bought at minus price of index, so we'll be selling it currently. So prices of index plus the index plus 1, the transaction has been completed, so count will increase by 1 and it will be 0. And we know like this count will be like count plus 1 will be less than equals to k, because we only performed this operation when the count was less than k. So this one last will have already means only become 1 when this count was less than k. So hence count plus 1 will be less than equals to k. Okay, and similarly the skip function here as well. And similarly for the third part where we will short buying it, so short buying will be minus prices of index, then again transaction will increase and the last will become 0, or we will simply skip it. And at each step we'll be updating our DP with the maximum of each step. Okay, so this was the the memorization code for this problem. We see the time complexity would be of the order of the number of states that we need to fill, which is n into k into 3. Okay, so we see like the k can go up to n by 2 and n can go up to 1e3. Okay, so k can go up to n by 2, so n square by 2 into 3. So simply like it is of the order of 1e6, which is completely fine because of the it is acceptable in the order of limits of 1 second. Okay, so let's try to submit the code as well here and see how much time it takes. This is the same code that we discussed, the memorization version. Let's try to submit it. I hope like you were able to segregate the transactions based on this last, and then it became very pretty similar to means pretty simple to write the code. Okay, because these are like redundant codes only, but it makes us more clear about the steps that we are doing at means based on different conditions. Okay, so now you might ask how can we write the tabulation code for this. So we have done it multiple times, so we know this index is dependent on index plus 1. So that means we'll be starting this index loop from n minus 1 and going till 0. Okay, now we see this count is either increasing or remains the same. So this count is also dependent on further values. So this count will be also starting from k and going till 0. Okay, and now this last can go either become 1 2 or it become 0. So last can go from either 0 to 2, 0 to 2, or 2 to 0, both are fine. Okay, and at each step when we have these values index, count and last, we'll simply we'll simply copy paste this in the tabulation code. Okay, we'll be simply copy pasting this in the tabulation code. And what will be the base case? So base case will be derived from here. We know since index equals to n, so the base case will become dp of n, and if last is 0, so for all counts last equals to 0, that means will be 0, and for all other values it will be minus 29. Okay, so the base case will be this. We'll be declaring a dp of size n plus 1, k plus 1 and 3, and then we'll be done. So this is pretty simple, writing the tabulation code once we have the memorization code. So I hope you were able to grasp the concepts, and if you did, make sure to like as well as subscribe. And if you yet have any doubts remaining on how to means approach these kind of problems, so I hope you will now solve these different parts of this problem on your own, and we try to solve the different parts, you will be able to grasp all the concepts. So yeah, this was pretty much it for this problem, and if you have any doubts, feel free to comment down. I will be happy to respond. Thank you so much for watching.